While companies market AI as an almost magical black box, we do know how LLM's core components work. This video will explore the basic framework behind the large language model, ANN and DNN. To understand how LLMs function, we need to focus on how their core processes work. LLMs are based on a framework called Artificial Neural Network, or ANN. An ANN is a computational model inspired by the structure and function of synapses in the human brain. But, and I need to be extremely clear here, it is not an artificial human brain in any way, shape, or form. In a brain, synapses essentially connect neurons to each other to transport ideas and messages. The AI version ignores all of the complexities of hormones and biological or environmental responses inside of the human brain, and is just an extremely basic reflection of how units of information are connected. The AI neurons, called nodes, are the units used to frame the computer network and are arranged in layers. The nodes are tied to each other between layers through connectors, which will weigh the relevance of each unit of information based on statistics generated from their past training data. Each layer's weights will impact the information sent to the next layer. So this is more of a probability model than a magic 8-ball of truth or a soul in a machine. With the artificial neural network, there are 3 layers to it. The first layer is the input layer, which is where you are typing in your prompt and pressing enter. It is anything that is inputted into the model. It goes to a hidden layer where calculations on the data occur, and then it is moved to the output layer, which is the final result of the network, meaning the answer that you receive from the model when you type something into Gemini or ChatGPT. This is just a very basic artificial neural network. This is like the foundation for LLMs, but it is not the thing that allowed LLMs to be what they are today. To make an LLM, we had to create more layers within the hidden layer area of the artificial neural network. In 2017, there was a breakthrough with neural networks called deep learning, which is a type of artificial neural network that has more than one hidden layer, so will have more than 3 layers total. As the picture shows, all of these dots, or nodes, connect to each other with tens of billions, if not trillions of layers like ChatGPT and Gemini have now. This deep neural network, or deep learning, is used for many applications, not just LLMs. I'm not going to get into it for this series, but for image and video recognition and generation, it uses a convolutional neural network for its technique. What I will be going into further is how LLMs use these deep neural networks as well as other techniques called recurrent neural networks or transformers to be able to understand the context behind your prompts. Recurrent neural networks are what are used for ChatGPT, Google Translate, and predictive text. This is the expansion of that basic ANN to more than 3 layers to create that deep neural network that will then be able to actually calculate context between your words. The basic ANN doesn't compute how words in your sentence relate to each other. It treats everything independently. RNNs uses techniques such as transformers and self-attention to keep that context, which will be explained in the next video. If you still have any questions, WCC Library is here to help. Feel free to reach out to us by email, phone call, text, or chatting online. A librarian will be available to chat with you Monday through Friday from 8 a.m. to 4 p.m.